Why the ocean is very salty? Have you ever thought about it? It's very simple to explain that. Actually, sodium and chlorine both are dissolved in the seawater. That is the answer. So, what is dissolving means? The general idea is a solid to be absorbed by a liquid, especially when mixed. Solutions can be found almost everywhere on the earth, from the oceans to the sky. Every ocean and every lake on earth is a solution. This is because the water has mixed with dirt, salt, and various substances to become a new substance. When rain touches the ground, it mixes with dirt, rocks, and so on, that it becomes a solution upon contact with the earth. The measure of solubility determines how substances dissolve into one another. The substance dissolving into the other is the solute, and the substance being dissolved into is the solvent. When you mix salt into water, the salt is the solute and the water is the solvent. So let's study the mechanism of the solubility with an example. So we all know sodium chloride. It's a stable salt. So how table salt dissolves in water? So basically, sodium chloride is soluble in water. The forces of attraction between the ions and the water molecules are strong enough to overcome the ion-ion and the water-water force of attraction. The force of attraction between the ion and the water molecule is known as ion-dipole attraction. In this tutorial video, we study which organic compounds are soluble in water and why they dissolve. Some organic compounds dissolve in water and some are not. When it comes to the solubility of organic compounds, there is a rule of thumb. The rule of thumb is that like dissolves like. That means polar solvents dissolve polar solutes and non-polar solvents dissolve non-polar solutes. For example, water is a polar solvent and it will dissolve salts and other polar molecules, but not non-polar molecules like oil. One of the important factors that affects the solubility of organic compound is intermolecular force. So in organic compounds, there are three types of intermolecular force. The first one is the hydrogen bond, the second one is the dipole-dipole force, and the third one is the London dispersion force. So if an organic molecule contains hydrogen bond, it is more polar, and if an organic molecule contains dipole-dipole force, it's less polar compared to the organic molecule which contains hydrogen bond. And if an organic molecule contains only the London dispersion force, then it is non-polar. So based on the information, an organic molecule which is having hydrogen bond is more soluble compared to an organic molecule which is only having dipole-dipole interaction. And it's worth noting that the carbon-hydrogen bond, or the non-polar part of the organic compounds, that means the alkyl part of the organic compounds, contain only the London dispersion force. Therefore, it is non-polar, so it will not dissolve in the water. There are some reasons which will decide solubility of organic compounds in water. So, the first factor that affects the solubility is the hydrogen bond. The attractive force between water molecules is dipole interaction. The hydrogen atoms are bound to highly electronegative oxygen atom, which also possess two lone pair sets of electrons, making for a very polar bond. The partially positive hydrogen atom of one molecule is then attracted to the oxygen atom of a nearby water molecule. So in this diagram, this oxygen atom of this hydroxy group is called the hydrogen bond donor, because it is donating its hydrogen to this oxygen. And this oxygen atom is called the hydrogen bond acceptor, because it is accepting the hydrogen from this oxygen. So water molecules could act as hydrogen donor and hydrogen acceptor simultaneously. And there are some atoms which could only act as hydrogen bond donor or an acceptor. For examples, aldehydes can act as hydrogen bond acceptor, not the donor, because aldehydes don't have hydrogen in their functional group. So in this case, inorganic molecules which can act as a hydrogen bond acceptor and hydrogen bond donor is more polar compared to an organic molecule which only acts as an acceptor or the donor. So when there are hydrogen bonds, for example, FH, OH, NH, between organic compound and water molecules, ability of dissolving in water is high. Organic compounds such as alcohols, phenol, aldehyde, ketone, carboxylic acids and amines can make hydrogen bonds. But remember that there are organic compounds which are insoluble in water and they can make hydrogen bond too. And the next factor which affects the solubility is the size of the alkyl group. So carbon hydrogen bond is not enough polarized to make hydrogen bond because the difference of electronegativity between carbon and hydrogen is very small. Therefore, carbon and hydrogen bond are non-polar. So hydrocarbon part of the molecule doesn't help to dissolve in water. So when hydrocarbon part of the molecule becomes simple or small, it increases the solubility. This means when a non-polar part is so large, that means the carbon hydrogen part is so large than the polar part, solubility decreases. Okay, with the information that we have learned so far, let's analyze this question. So basically we have four answers. The first two answers are, that means the A and B are alcohol, and the C is aldehyde, and the D is alkyl chloride. So based on this, first let's check the hydrogen bonds. So the A and B are alcohol, so therefore it can make hydrogen bonds. Especially these alcohols can act as a hydrogen bond acceptor and the hydrogen bond donor because it has the hydroxy group which has the hydrogen atom. And the next thing, the C, that also can make hydrogen bond, but the C is an aldehyde. It doesn't have a hydrogen atom connected to oxygen. Therefore, it can only act as hydrogen bond acceptor, not the donor. So it is less polar compared to alcohol. And the D is alkyl chloride, so it cannot make hydrogen bond. It has actually a weak dipole. So therefore, it doesn't dissolve in water. The first answer, the A, that has a long hydrocarbon chain, that means a long alkyl group. So it is very hard to dissolve in water. But the B has a small hydrocarbon chain, so therefore it can dissolve in water better than A. So when we organize this in an ascending order, the least one that is insoluble is the D, that is alkyl chloride, and the next one is the C because it can act as a hydrogen bond acceptor, not the donor, so that is less polar compared to the alcohol. And we have two types of alcohol. The one that is A has a long carbon chain and the other one has a small carbon chain. So the B has a small carbon chain, therefore it is more soluble than the A. So the A comes next and the last the B. So the answer is the second one.